Yeah.
All right, so this skill is a little bit challenging, can be a little bit tough. What we're doing is we're drawing on a number of things we've already learnt and bringing them together, okay? So remember we've talked about tangents, and this textbook exercise is about tangents and normals. To begin with, we will just focus on tangents. So this is a massive exercise in the textbook, and we're mainly interested in question 1 and 2, just bringing those steps together. So we'll focus on that, and maybe in the next lesson, which will be on Thursday, we can start to address some of the more complex ones. We'll see how we go. I just want to make sure you can master this skill, equations of tangents. So let's just recap. If we have a curve, a tangent is a line that is parallel to the curve at a particular point. So if this is the point and we draw a tangent, it's going to be that line there. What we're doing today is finding the equation of that line. Okay, so we've got a number of steps involved in this process. Now I'm going to record steps. And the other thing is there's basically 3 processes you can use, which can complicate it a bit as well. So I'm going to teach what I think is the most effective process. And then maybe with some of the later questions, we might look at alternative processes, see if you feel you would prefer one of those. So the first thing we need to do, so we're finding tangents. We've got question 1 here. All right, it says, find the equation of a normal and a tangent at x is minus 3 to this curve. And the curve we have is y equals x squared plus 2x. Okay, we're going to find the tangent at x is minus 3. Okay, so I'm going to make a list of the things that we need to find first. First, we need the point of contact, the POC. All right, so that means we need the coordinates, not just the x value, not just the y value, we need the point of contact. We go, when x is minus 3, what is the corresponding y value? So we'll go, when x is minus 3, y is going to be, and we put that minus 3 into this equation, right? Minus 3 squared plus 2 times minus 3. Okay, so this will bring up 9 take 6, and we'll have 3. And we've got the point of contact, okay? You get 1 mark for stating the point of contact. X is minus 3, y is positive 3. Okay, the next thing we need is the slope. We need to know how steep is the curve. And so the whole point of calculus, right, is remember we have a function, and if we differentiate it, so differentiation is the process, differentiate, we arrive at f dash of x, which we call the derivative function. Okay, the function, if we differentiate it, we get the derivative function. What does the derivative function tell us? It tells us the slope for any value of x. So that means we've got this function here. We need to differentiate it and find the slope when x is minus 3. Okay, so step 1, find the point of contact. Step 2, to find the slope, we're going to say, okay, the derivative function, dy on dx, we're going to use simple differentiation. So I'm looking at this, x squared plus 2x. Well, the derivative of x squared is 2x. Okay, so I've differentiated that term, and the derivative of 2x here is 2. Just using the power rule. We've got the derivative function, and we want to know the slope. So now we're going to put x is minus 3, because that's the point of contact, right? That's the x value, into this equation. So we'll have, when x is minus 3, dy on dx is 2 times minus 3 plus 2. All right, putting that x value in there. Minus 6 plus 2, minus 4. So we've got everything we need, right? We've got the slope and the point of contact. Now all we're doing, okay, so we've done that skill before, we've done that skill before. Now we're drawing them together and we're finding the equation of a line that passes through this point that has a slope of -4. We're finding the equation of a line. That's a skill we've done before. So what you can see, we're just drawing 3 skills together to find the equation of a tangent. So the equation of a line, okay, is y equals mx plus c, where m is the slope and c is the y-intercept. What's the slope of our line? -4. The slope of the line is -4, so we've already got the value of m. So we'll write y equals -4x plus c. Then we need to determine the value of c, and we do that by substituting in the point of contact. We've got when x is -3, y is +3. So we're going to put +3 where the y is and -3 where the x is, and solve for c. -4 times -3 is +12. Okay, so the value of c is -9. So we've got 3 equals 12 plus c, take away 12 from both sides. C is -9, which means the equation of the tangent is -4x to take away 9. Okay, that is the equation of the line that will touch the curve at x is -3, y is +3. Okay, so what's the process? Find the point of contact, find the slope, and then find the equation of the line by putting in the slope and the coordinates. So there's a bit going on, right? You can break down each step further, but they're the 3 steps we need to do. Find the point of contact, find the slope, and then find the equation of the line. So we've got, step 1, step 2, step 3. Okay, let's do the second example then. So it does say find the equation of the normal. We won't do that yet. I reckon let's just dedicate this whole lesson to tangents, okay? We'll just dedicate this whole lesson to tangents so we don't obfuscate the content. The next one is we have the function of x is the square root of x. And it says find the equation of the tangent in y-intercept form. So they've specified here, find the equation of the tangent in y-intercept form at x equals 4. All right, so start with point of contact. All right, always start with the point of contact. We've got the x value is 4. The y value is going to be the square root of 4. The square root of 4 is 2. Point of contact. Done. Okay, part 2, find the slope. Now, if we want to find the slope, we need to differentiate. We need the derivative function. The derivative function tells us the slope for any value of x. So to find the slope, we have the function is the square root of x. And remember I've said if we want to differentiate it, we need to express it as x to the power of n. So the square root of x is x to the power of half. All right, I'll write the power rule up here. I sort of assumed it before, but if we have x to the n, the derivative is nx to the n take 1. So that's now what we're going to apply to this function. Here's the function. Let's differentiate it. So x to the n becomes nx to the n take 1. Half take away 1 is minus half. I've done it all in one step. Now, we want the slope when x is 4, okay? We want the slope when x is 4, which means we're finding f dash of 4. Okay, now at this stage, you can type that into your calculator if you want to. Half times 4 to the minus 4, you can type that in. I'm just going to keep going and solve it manually. Remember I've said, okay, if we have to the power of minus half, one thing we can do is take it to the bottom, right? So we've got this half out the front, that's going to be that half there. We've got this 4 to the minus half, so I can put it at the bottom and make it 4 to the half. Okay, they're multiplying. And 4 to the half, that means the same as the square root of 4. And the square root of 4 is 2. Half times a half, 1 on top of 4. All right, so you can type that into your calculator up there. I do encourage you to be competent with these skills, especially if you're going to do Year 12 methods next year. All right, let's make a little bit of room here then. So we've got the point of contact and we've got the slope. The slope we found was a quarter. All right, so we've got the slope and we've got the point of contact. Find the tangent in y-intercept form. All right, so once you've got these two things right, this is where there's 3 possible processes. And the one I showed you here is the one we've been familiar with, finding the equation of a line in y-intercept form. We're just going to repeat that process now, okay? We'll repeat that process now. So we have y equals mx plus c. So this is step 1, step 2, this is step 3. The slope is a quarter, so we have y equals a quarter x plus c. And the point of contact is 4 and 2. We've got when x is 4, y is 2. Okay. So we're going to put those coordinates into this equation. We'll have 2 equals a quarter times 4 plus c. We put 2 where the y is. We put 4 where the x is. Now, a quarter of 4, a quarter times 4 is 1. And so c has to be 1. If 2 is equal to 1 plus c has to be 1. Which means the equation of this tangent is a quarter x plus 1. All right, how do we feel about this skill? Not too bad? All right, so I think what we'll do is get you guys to have a go. All right, so we're drawing on those. I'm going to pause there. I know there's another example, but we'll come back to that when I teach an alternative process. Okay, we'll come back to that when I teach an alternative process. So we're drawing on, find the point of contact, find the slope, and find the equation of the line. All right. So yeah, I'll stop it there.